Dichromatism is a phenomenon where a material's solution's hue is dependent on both the concentration of the absorbing substance and the depth or thickness of the medium traversed. In most substances which are not dichromatic, only the brightness and saturation of the color depend on their concentration and layer thickness. Examples of dichromatic substances are pumpkin seed oil, bromophenol blue and resazurin. When the layer of pumpkin seed oil is less than 0.7 mm thick, the oil appears bright green, and in layer thicker than this, it appears bright red. The phenomenon is related to both the physical chemistry properties of the substance and the physiological response of the human visual system to color. This combined physicochemical physiological basis was first explained in 2007. Physical explanation. Dichromatic properties can be explained by the Beer-Lambert law and by the excitation characteristics of the three types of cone photoreceptors in the human retina. Dichromatism is potentially observable in any substance that has an absorption spectrum with one wide but shallow local minimum and one narrow but deep local minimum. The apparent width of the deep minimum may also be limited by the end of the visible range of human eye. In this case, the true full width may not necessarily be narrow. As the thickness of the substance increases, the perceived hue changes from that defined by the position of the wide but shallow minimum to the hue of the deep but narrow minimum. The absorbent spectrum of pumpkin seed oil has the wide but shallow minimum in the green region of the spectrum and deep local minimum in the red region. In thin layers, the absorption at any specific green wavelength is not as low as it is for the red minimum, but a broader band of greenish wavelengths are transmitted, and hence the overall appearance is green. The effect is enhanced by the greater sensitivity to green of the photoreceptors in the human eye, and the narrowing of the red transmittance band by the long wavelength limit of cone photoreceptor sensitivity. According to the Beer-Lambert law, when viewing through the colored substance, the proportion of light transmitted at a given wavelength, T, decreases exponentially with thickness G, T equals E minus at, where A is the absorbance at that wavelength. Let Ge minus A Gt be the green transmittance and Re minus R be the red transmittance. The ratio of the two transmitted intensities is then A. If the red absorbance is less than the green, then as the thickness D increases, so does the ratio of red to green transmitted light, which causes the apparent hue of the color to switch from green to red. Quantification. The extent of dichromatism of material can be quantified by the Crafts dichromaticity index. It is defined as the difference in hue angle between the color of the sample at the dilution, where the chroma is maximal, and the color of 4 times more diluted and 4 times more concentrated sample. The two hue angle differences are called dichromaticity index towards lighter and dichromaticity index towards darker respectively. Crafts dichromaticity index landed for pumpkin oil, which is one of the most dichromatic substances, a -9 and -44, respectively. This means that pumpkin oil changes its color from green-yellow to orange-red when the thickness of the observed layer is increased from cca 0.5 mm to 2 mm, and it changes slightly towards green if its thickness is reduced for 4-fold. History. A record by William Herschel shows he observed dichromatism with a solution of ferrous sulfate and tincture of nugget in 1801 when working on an early solar telescope, but he did not recognize the effect.